Okay, so welcome to week 4. We're going to cover the first part of chapter 8, and chapter 8 is getting more in details of basically using classes and a little more new things that we haven't covered before. First few parts of chapter 8 start getting in more depth of the static argument that basically we can put on different fields and or methods. And so the book kind of talks about it. Says that it is possible to create a field for a method that does not belong to any instance of a class. So I can create a field that doesn't belong to anything. It's just there by itself. It says when a value is stored in a static field, it is not stored in an instance of that class. So if you have a static field, that means it's there by itself. It can be used by itself, doesn't have to go along with any other class. It's just there, ready to be used. This is when a static field is detected with the keyword static, there will only be one copy of the field in the method. Okay, so what that means is once I have that instantiated, that static method, which is it's automatically instantiated, I should say, if I leave that method and I come back to it, that static method never went away. So local variables basically are born and die with the instantiation or use of that method, and as soon as we hit that last close brace, that variable goes away. So with a static method, it's there, or I should say static field, it's there all the time. It basically never goes away. So let's take a look at countable over on page 498, and here we have, it's basically public class countable, and it says private static int instance is equals 0, and then it says public countable. So this is a constructor because it's the same name as the method, or I should say same name as a class. And I say instance count plus plus. So here's my instance count up here. It's set to 0. I say plus plus, and then I have a get. So I've got a getter, no setter. So if we take a look at, it's called the static demo, and we look at that guy, we can see that it is a class, static demo, and it's got a void main method. So this is executable. And it says countable object 1 equals new countable, countable object 2 equals new countable, and countable object 3 equals new countable. So I'm creating 3 separate objects, object 1, object 2, and object 3. And they're being instantiated from the countable. Now if you remember from countable, there I have a static instance count. So it's a static instance variable. So that means it's instantiated as soon as it is executed once, and it's set to 0. So now in any other, if any other type of a instance variable without the word static, this guy is created right here when it's instantiated, and then this guy would add 1 to it, and then when we said get the instance variable for that object, it should say 1. Well, if we take a look at static demo, when this object is created, there's that static instance variable. Remember, static means it's not attached to that class. It's standalone. So when it executes object 2, guess what? It's hitting that same static variable, which already has a 1 in it because the constructor adds 1 to it. So this guy's going to add 2 to that same static variable, or add 1, so it becomes 2. And this one, so even though I have 3 separate objects, I only have 1 of that static method, and it's shared by all 3. So think of it that way. So if we execute this, the static demo, if I run it, it says there's 3 instances. So down here it says, tell me how many, it says get instance count. How many instances, so it says 3 instances of the class were created. So what if I did this? In countable, I get rid of the word static, and it executes. Because look, if we go back here, it's actually using object 1. Okay, so object 1 says there was 3 instances created. I only called object 1 once, but I also added to that field an object 2 and object 3. But now that it's no longer static, watch what happens when I run this. it comes back and says 1 instance. Why? Because now that instance variable lives and dies, and it's attached to object 1 now. Because that we create that object 1, it instantiates that instance variable one time, that's it. Whereas if I make it static, that variable lives outside of the class basically, and it lives and dies with the project at that point. So again, when I add 1 to that static variable, it's being added for all 3, even though it's in that once. So think of it kind of a global variable in a sense. Okay, so that's basically when we create a variable static. It lives as soon as the project's ran, and then, or I should say, let me back up a little bit. It lives the very first time that line is executed, and it does not die until the project ends. Okay, so when that guy gets created, it's living there and it's set to 0. I add 1 to it here no matter what object is instantiated from this class. So object 1 instantiates a new object 1. We basically instantiate object 2 from the same class, so this guy does never get executed again, because it says, oh hey, it was executed once because it's static. Let me add that back in there. It's executed once the first time because it says, hey, since I see the word static, does this guy exist already? It doesn't. It goes ahead and creates this variable and initializes it to 0. The next time we instantiate this class, it comes in, it says, hey, does this static instant count live? Yes, it does. I'm not going to execute this line. So when it comes down here and adds 1 to it, it adds 1 to that static variable. Okay, so that's how we can do that. So now let's go over to static methods, and we're going to take a look at metric. Now metric it's a class, but the classes we're used to have constructors, and they have getters and setters. In this case, it's just a class. It's kind of a standalone class, and it has 2 static methods. And these static methods are returning a double, and they're receiving a double. So this double is going to be miles, and it's going to return miles converted to kilometers. Okay? And this guy does the same thing. It's returning a double, it's receiving a double, and it's going to receive kilometers, and convert them to miles. Now, since this is static, it's already instantiated. Doesn't have to be we don't have to instantiate it or anything. It's ready to be used at face value. So if we run the metric demo, so let's take a look at it. I'm creating 3 variables, local variables, input, miles, and kilos, and decimal format, so I'm using the decimal format class. Input, I'm basically getting input from my J option pane, and I say miles equals double parse input. So whatever I get from this, because input is a string, I convert it to double and throw it into miles. Kilos, I basically then say kilos is equal to metric. Notice I didn't even have to instantiate metric. Wow. Usually when I need to use a class, I have to instantiate it. Now in this case, I'm using the static method, which doesn't need to be instantiated, so I say metric, miles to kilometers, and I'm passing in miles. And it converts to kilometers and passes back a double and throws it into kilos. And then I say J option pane, miles equals, boom, so it basically displays to the user what it looks like when we convert miles to kilometers. And then I do the same exact thing for kilometers to miles. And in this case, here's metric. Again, metric has not been instantiated, but the method is static, so I don't have to worry about that. Now if I had a regular local method to metric, I would have to instantiate metric as an object. So if we run this, it comes up and says distance in miles. I'm going to say 100. I click OK. When that gets converted, it gets converted to 160. 160.9 kilometers. I click OK. I'm going to say 100 kilometers, and that comes back as 62.15 miles. So as you can see, no instantiation of a class. We just use that static method right there at face value. So pretty cool stuff there. On page 504, we have the passObject.java. So if we take a look at that, there I have a class called passObject, and there I've got my void main, and here I'm saying rectangle box, so I have a rectangle class, and I'm instantiating it as a box, so it's a new, and I'm passing in 12.0 and 5.0, so there must be a constructor receiving two doubles. And then I say display rectangle box. So here it's in italicized, so that means it must be a local static method, and sure enough, here it is, public static void display rectangle, and I'm passing in the object box. And down here I'm receiving a rectangle object called R. And I say sysout length r.get width. So basically the whole point of this is it's a static method and it's receiving the object, and then we just use the object via the methods. So r.getLength, r.getWidth. So not too bad there. And if we look at rectangle, it's just a standard class where it has two instance variables, length and width. We have a constructor that receives those two doubles and returns, or basically sets those two instance variables. And then I've got set length, set width, get length, get width, and we also have get area, which calculates area as well, which we didn't use. So if I run this guy, the length is 12.0, width is 5.0. So not too bad. So basically you got a static method passing in an object to it, receiving an object. So not too bad. So that's basically that's going to put us right up to 8.3 lesson. So let's go ahead and break there, and we'll put this video out there on YouTube, and we'll see you in a little bit.